we refer to the asymptotes, right? I did talk about them, but I didn't talk about, well, how do you get them, okay? It's not that hard. You can just think about limits, and in some sense that's what I'm going to do, but you can also have a formula approach to it. Just watch what happens. How do I get an asymptote? Like if I gave you some random rational function, something like, I hope everyone wrote down that homework, anyway. Something like this. Okay, how would you go about working the asymptotes out for that, whether they're horizontal or oblique? Well, first question, are they horizontal or oblique? It's not a trick question. That's a bit of a worry. Okay, they're horizontal. We'll spend more time on this later. The easy way you can tell it's horizontal is that the degree of the numerator is less than the degree of the denominator. So think, what are horizontal or oblique asymptotes about? They have nothing to do with the center of the graph. They're only about the edges, which is why you can cross them willy-nilly, right? But as x approaches infinity, which one takes over, the numerator or the denominator? Answer, the denominator, big time. Doesn't matter if there's like a million of these guys up the top, okay? The x squared will always take over in the long run, right? So, okay, so as x approaches infinity, right, y approaches 0, so fine, okay? Now, in order to work out, therefore, what's happening in this scenario, okay, I need to get it in a form where I can say y is equal to something, so then I can see how it's behaving, okay? So this is kind of not a very useful form to put it in, so let's make y the subject. What have I got here? Y squared on b. Is that okay? I've just switched around the y squared on b squared and the 1. Just, okay? So now I guess I would divide, sorry, that's a b squared. I would divide through by b squared, so that gives me 1 on b squared. Times all of that. Okay? And hold on, what have I done? Sorry, what have I done? I should multiply. That's what I should. Okay, now what do? I should take the square root, shouldn't I? So now by the way, you're gonna get plus or minus, but do you see what that signifies? Because you got 2. Here's the plus and here's the minus. So no big deal. I'm going to be naughty. I'm just going to write down one of them, okay? Don't kill me. So I've got the b and then x squared on x squared minus 1. And we'll consider this case and then just slap a minus sign on it for the other one. Okay? Now this is okay. This is okay. But I can do a little better than this, right? I'm trying to work out what happens as x approaches infinity. Aren't I? What's going to happen? Because at the moment, as I consider x to infinity, it's not a useful result to me. Okay, this is what I'll do here. Okay? So limits are useful when you've got things that vanish off to infinity or 0, right? So that's why I take out this guy. Okay, watch what happens, right? If I took out x squared on a squared, it becomes x on a out the front. Yes? So what's left here? That becomes 1. And this becomes, because I divided, so that's a squared on x squared. That's what I wanted. Okay, good. Right. Okay, now can you see where the limit's going? Right? Because as the limit, as x approaches infinity, this guy, what happens to it? Disappears. So you just get the square root of 1. Just 1. So you're approaching this, which is a straight line, namely your asymptote. Okay? Happy with that? So you actually can just read off 25 and 9. You're fine.